All right, Math 8. So last time we talked, we were taking things from standard form, or just like a number, and making a scientific notation. Now we're going to go backwards, kind of like I hinted at, okay? If you can do one way successfully, you should be able to do the opposite way. So here we go. Example 1, we have 3.21 times 10 to the 5th. Okay, when we do this, we need to make this into either large number or small number. If you recall, positive exponent tells us that it's going to be a large number. So no matter what, you know this is going to be something, like 3 and a bunch of zeros after it and stuff like that. It's not going to be 0 point stuff. It's going to be a giant number, okay? So first step I want to do is rewrite what you have, 3.21. Okay, now, a lot of people refer to this as, oh, I should move it right or should I move it left? Move the decimal so you make a big number. Okay, because once you start talking about right versus left, then when we're going backwards, people will ask, oh, do I move it right or left? And it gets kind of confusing. So just move the decimal so that you make a large number. Well, in this case, it would go right, but I move it 5 times, okay? It is not adding 5 zeros. It's moving the decimal 5 times. So the first 2, I move it to the other side of that 1, and I still got to move it 3 more times. 1, 2, 3. Add your zeros in the little loops. Okay, and then we don't want to leave it ugly looking like that. Just rewrite it. So we have 321,000, and that's our answer. Okay, move the decimal. Do not add zeros. Move the decimal. Okay, example 2. Rewrite the number, 8.73. And we're going to move this one 4 times. However, it's a negative, so we need to make a small number. Negative exponent, small number. Okay, so I'm going to move it 4 times. I move it once to the other side of the 8. Again, not just adding 4 zeros. And then I need to move it 3 more times. I plug in my zeros. Okay, so this one, we have 0.000873. Okay, a lot of times I'll just put a 0 in front of this decimal just to make it look a little bit cleaner, and it kind of shows that there's no whole number. Okay, and this is our answer. Okay, go ahead and pause it. I'm going to throw 2 more examples up there. Pause the video, try them yourself first, then go ahead and hit play and figure out the solution. So again, pause if you need to, try them on your own. Otherwise, here we go. So I have 4.99 times 10 to the second, okay? It might seem a little bit different when we get to the answer, but you'll see it's still the same process. Write your number down, 4.99. Okay, we have a positive exponent, so that means we need to make a large number. So we're going to move the decimal to make a large number, 1, 2. So then I have 499. Problem solved. Okay, yeah, it doesn't seem like a crazy large number, but it is in fact a large number. Remember, a large number is simply not a decimal, not 0 point stuff. A large number could be 2.4, could be 2, could be 9, could be 12, okay? That's your answer, 499, okay? Don't get confused by it. Example 4. Just because we have a negative here doesn't change the process, okay? The number's negative, it's fine. It's still the exact same process. So I'm going to rewrite negative 2.04. And again, it's a negative exponent, so I need to make a small number. So let's move it to make a small number. Move it 3 times. 1, 2, 3. So now I have 0.00204. Okay? We can't forget the negative. Again, I'll put a 0 in front of the decimal, and it's still a negative number. The negative number does not change the fact that you still move it to make a small number or move it to make a large number if it was a large number. Okay, just because it's negative doesn't change the process. Okay, that's it for today. Make sure you pause and get a good look at this. From here, you have a little practice, and then we're going to be moving on to multiplying, adding, and stuff like that with scientific notation. Have a good one. I'll see you next time.